Hello everyone, I am Professor Amit Solanki from S&D College of Engineering and Research Center, Yeola. Now today we'll discuss about the next topic, that is the single phase fully controlled converter fed DC motor drives. Before starting that, we should have to know that what are the concept of the speed control of DC motor by the controlled converter. As you know that previously the conventional method of speed control for DC motor drive was is given by the formula, that is N is equals to E of B divided by phi. That means we can vary the speed by varying the resistance in armature circuit, or we can say that the rheostatic control, by varying the flux, that is the flux control, by varying the applied voltage, that means voltage control. Okay, so these are the some conventional method, or we can say that the old method. So these are not efficient or reliable. So for that we are moving towards to the solid state speed control of the DC motor. Okay, so the DC motor speed can be controlled through power semiconductor switches. Here the power semiconductor switches are SCR, that is silicon control thyristor, which is MOSFET, metal oxide semiconductor field effect transistor, IGBT. This type of speed control is called Watt-Leonard drives. Okay, so these are some example of the solid state speed control of the DC motor. Now let us understand the detailed concept of the speed control of the DC motor. The speed of DC motor can be controlled very easily by means of regulating its supply voltage by the use of phase controlled rectifier, and this control can be applied to either the field or the armature circuit. Okay, and the motor responses with armature control is faster than that with field control, since the time constant of the field is very much larger than that of the armature. In generally, the field control is used for speed above rated value and armature control for speed below rated value. Right? The control rectifiers, either single phase or multi-phase, are widely used in DC drive applications where AC source is available. Okay. So this is the concept for the speed control of DC motor by the controlled converter. Now in this slide we can see here the types of DC drive. So we will see one by one what are the different types of DC drive. First one is phase control rectifier fed DC drive according to the input supply. So according to the input supply, the speed control converter there are two types. One is single phase rectifier fed DC drive and three phase rectifier fed DC motor drive. So these are the two types of controller according to the input supply. Second one is according to the quadrant operation. According to quadrant operation, it is also classified in three types. First one is the one quadrant operation. Two quadrant operations and four quadrant operations. And second one is a chopper fed DC drive. The chopper fed DC drive, that is the one quadrant chopper drive, two quadrant chopper drives, and four quadrant chopper drives. So these are all about the types or classification of DC drive. The single phase or multi-phase AC is converted to DC by controlled rectifier or converter to give a variable DC source. Now let us start our today's main topic, that is the single phase fully controlled converter fed DC motor drive. In that we can get the variable or fixed AC to variable DC supply by varying the triggering angle of the thyristor or any other power semiconductor devices that could be supplied to a DC motor, and thus the speed of the motor can be controlled. Okay, so single phase control converter drive, according to the block diagram you can see here, this is the AC source. Okay, and this is the phase control rectifier. This is the DC motor connected, and this is the load. In that block diagram you can see here, this is the functional block diagram of the single phase control converter drive. This is also the single phase control rectifier phase separately excited DC motor drives. Okay, in that circuit diagram you can see here is connected to single phase AC supply. This point is 2-point phase and neutral. As you know that in single phase there is only 2-point phase and neutral. This is a single phase control rectifier which have to convert fixed AC into variable DC. And this is the RLE load. You can say that this is the armature current, resistance of armature, inductance of armature, the back EMF. This is armature connected. This is also field connected. So this is the separately excited DC motor. So we are also providing field supply through the rectifier. These are all about the concept for the single phase fully controlled rectifier. Now this is the simply circuit diagram. In this circuit diagram of single phase full wave fully controlled converter drive for controlling a separately excited DC motor. As you see, observe in this diagram, according to that we can control the speed of the DC motor. Here is the source voltage, this of T, and here is the thyristor are connected. In single phase fully controlled converter there are 4 thyristors are connected, T1, T2, T3, T4, and freewheeling diode is connected for preventing the current. Okay, load current, and this is the load that is connected to the RLE load. This is the armature winding, this is the field winding. Field winding is also provided the DC supply from the rectifier, which is diode rectifier. Okay, so let us understanding the detail about that. Here a full rectifier which supplies the field circuit while the full converter supplies the armature circuit. Okay, the converter has 4 thyristors, as we already discussed, that need alternate switching of the pairs of this thyristor, that is T1, T2, 3T, T4. The converter provides armature voltage R plus VA or minus VA depending upon the value of the triggering angle alpha of the thyristor. So therefore 2-quadrant operation is possible. Armature current remains unidirectional due to the converter configuration. The vast majority of shunt motors are also controlled in this manner. So this is all about the functional diagram of the single phase fully controlled converter fed DC motor drives. Now single phase full converter operation with continuous motor currents. There are 2 modes of operation, continuous and discontinuous. In that we will see by the waveform. So the waveform of voltage VA across the armature and the current armature through the armature are shown in figure for continuous current of mode of operation. So in that waveform, in this slide you can observe This is the overall figure or waveform graphical representation for the single phase fully converter fed DC motor drive. Here is the input voltage, or we can say that the sinusoidal voltage pi 2 pi. Okay, and this is the output voltage. Output voltage, that means in that we have provide the firing angle. This is the alpha. So firing angle are, it is nothing, is that the instant where thyristor start conduct. So at that point, the SCR should get conduct and operate the process. So it is used, it is comes into negative because due to the inductance. So for that, during that time, it will be conducted, and again we will fire the alpha from pi plus alpha, and it is on, so on the process will be continue periodically. And this is the armature current. Okay, this is the output current and armature current. This is the continuous mode operation. Okay, these are the waveform for the single phase fully controlled converter where DC motor drives. In any case, it is obvious that the thyristor only conduct when supply voltage exceeds the back EMF. Okay, that means Vm sin A is greater than armature EMF. When thyristor T1 and T2 triggered at omega t is equal to alpha, then thyristor T3 and T4 must be turned off. When thyristor T3 and T4 are triggered at omega t equals to alpha plus pi, the negative voltage is applied across the T1 and T2, causes them to commutate naturally. And the average value of the armature voltage can be derived as, so according to that, now we will find out the average output voltage formula through this equation. So armature voltage VA average is equals to 1 upon 2 pi integration of 0 to 2 pi VA of omega t d omega t. Now we can solve this equation and find out, this is a 2 upon 2 pi integration of alpha to pi plus alpha. Put the value of VA, that is the Vm sin omega t upon d omega t. So after solving this equation, we are getting VA is equals to, this is the VA, that is the average voltage. Our average output voltage, that is the 2 Vm by pi cos alpha. This is the formula for the output voltage of single phase fully controlled rectifier fed DC motor drive. Now we can find out the average current. According to that, we can get 2 Vm by pi Ra cos alpha minus E upon Ra. Now we can find out the power factor and power equation with the help of this phenomena. So this is the efficiency P out upon Pn. We can put this value and find out the value of efficiency, that is EAI upon Pn. Since the input current is RMS value equal to that of motor current, so therefore the operating power factor is equal to P upon EM upon root 2 dot EL. So this is the all about the concept for the our equation, our output voltage equation, that is the fully controlled rectifier. Now in this figure you can see here, this is a graph, or you can say that the characteristic of the single phase fully controlled converter, the DC motor drive. In that you can see here, you can observe when we increase the alpha, that is firing angle, that is a 0 degree. So at 0 degree we are getting maximum speed. At 60 degree, if we are increasing the value of alpha, that time we are getting less voltage or less speed. This is the continuous mode conduction and this is the discontinuous conduction. So thank you for watching this video.